Okay, let's continue our discussion on photoelectric effect experiment. Okay, so if the positive voltage is gradually decreased, the current, photocurrent, will also decrease slowly. He says that if the voltage decrease, the current will also decrease. So what it means here is just now we start with 10 volt, isn't it? We start with 10 volt. And just now I did say that there are 10. Let's say there are 10 photons coming. There are 10 photons coming. So there are 10 electron. There are 10 electron ejected. Yeah, 10 electron ejected. Okay. So but however at 10 volt, you only have 6 electron reach the anode. Only 6 electron reach the anode, and then you increase to 20 volt. Increase to 20 volt, then you have 7 electron reach the anode, and then you have increase to 30 volt, you have 8 electron reach the anode. So that's why you can see the current increase. Yeah, the current increase. Also increase reading. Okay, the current over here in the galvanometer increase reading. So the current at first is with current only 6 electron, and then go up to 7 electron, and then go up to 8 electron. Finally, is 10 electron is the saturation current. Yeah. Is saturation current when you have the total of 10 electron reach. That is the maximum already, isn't it? That's the maximum electron. If we have 10 electron reach the anode, 10. Yeah, you have 10 electron. That is the maximum reach saturation. Okay. As you increase the voltage, increase the voltage some more, up to 40 volt and so on, increase the voltage. So the current also increase. However, the current here also increase. However, if you, let's say you decrease the voltage now, the current also decrease. That means now I decrease the voltage, become, let's say 5 volt, decrease. So now the electron that will reach, for 10 volt, if 10 volt, there will be 6 electron reach the anode. If 5 volt, there will be only 5 electron. There will be only 5 electron reach the anode. And then you decrease some more, decrease some more, So if the electron that reach the anode is decreasing, the current also decrease. So if you decrease the voltage until 0 volt, what will happen? If you decrease until 0 volt, at 0 voltage, there are still some photoelectron that with sufficient energy reach the anode. Still some will reach the anode, and the current now is I naught. So as you see, at 0 voltage, there are still I naught. At 0 voltage, there are still I naught. There are still current. So maybe at 0 voltage, there are only 4 electron that reach the anode. That's the I naught really lah. It will decrease until I naught now is only 4 electron. Only 4 electron reach the anode. Okay. But my question is, why at 0 voltage? There are still electron flowing? Why there are still electron flowing at 0 voltage? As you have learned that where the electron gain energy, there are 2 ways the electron gain energy. One from the power supply, one from the electromagnetic radiation. I think you have learned in chapter 3. Let's look back to chapter 3. Not this chapter 3. Okay. Electromagnetic conduction. Why the electron can flow in the circuit? Why it has the energy to flow in the circuit? Because the electron is being pumped by the battery, isn't it? It's being pumped by the battery. The battery actually is the energy source. The battery potential difference provide the energy to make the electron flow in the circuit. So one way the electron gain energy to flow in the circuit is from the battery. Yeah. Let's go back to our chapter 9. So one way the electron can flow in the circuit is because it is being pumped by the power supply. The power supply gives energy for the electron to flow. Another way for electron to flow in the circuit is it gain energy from the light. Do you see that? So you see, the electron, where he gain energy. Last time is only the battery. Only battery give the energy. Now the light also give the energy. Okay. Electron. Why the electron can flow in the circuit? Electron flow because it gain energy from battery. Another is it gain energy from light. Yeah, because for battery we have EMF equal to IR plus IR, isn't it? It give energy. For light, it has the energy equal to HF. The light give the energy. So look at further on this one. This is actually the photoelectric equation. The energy of light, HF, provide kinetic energy for the electron. Yeah, you look at the I haven't teach about this one, but I will teach later. You see that the photon has energy HF. It provide all the energy HF for the electron, and the electron will gain kinetic energy. So that's why the electron can flow although there are zero voltage. Look at this one. Look at this figure. Yeah. Look at here. This one is zero voltage, but current is, you still have current. Why at zero voltage there are still current? The electron gain energy. It doesn't gain energy from the voltage anymore, because voltage doesn't provide any energy. But this electron gain energy from the light, from the photon. It has the kinetic energy. Again, this kinetic energy, and this kinetic energy actually comes from the energy of photon, HF. As I said, one photon eject one electron, and the electron receive all the photon energy, HF, from the photon. It just absorb the whole photon. This electron will just absorb the whole photon energy. It gain all the photon energy, HF. That's why the electron gain kinetic energy to flow by itself. Yeah, to flow by itself. Let's look back to our So electron, besides gaining energy from battery, you also gain energy from light. So even though you put what I can say, even though you set the voltage, you set the EMF become 0 volt, but never mind, the electron still can flow. That means it's like in the circuit like this. It's like in a circuit. This is the cathode, this is the anode. Okay. Before this we know that to make the electron flow, there must be battery, isn't it? There must be battery with 10 volt. Then only you got current. Then you only got current, isn't it? Resistor. Then you got current, maybe 2 ampere and so on. Got current flow. You have current because you have battery. Now what if you make the battery 0 volt? What if you make the battery 0 volt? Then the current will become 0, isn't it? it should be current become 0 because the current is the electron flow, yeah, actually a flow of positive charge, yeah, but the electron cannot flow anymore because it does not gain energy from the battery. Does not gain energy from the battery. You set 0 volt, so the current should be 0 because we know that from this formula, E equal to IR plus IR. If your E is 0 volt, the current will surely get 0. But the thing is, why in this PowerPoint, look at this diagram. Here voltage is 0, but why still got current? Look at here. Why the electrons still flow? Although there are 0 voltage, no EMF, no more EMF, E equal to 0, but why still got current? As I said, this electron gain energy from two sources. It either gain energy from the battery or it gain energy from E equal to HF, the photon energy. Since now the battery no more energy, no more provide energy, so the energy of this electron actually all come from the light. Understand? So it still have the energy from the light, and it still have enough kinetic energy to reach the anode. You see, some of the electrons still able to reach the anode. That's why still got current even though 0 voltage. Okay, I hope you are clear. Let's go back. Okay, so so that means although now the voltage now you make you make here EMF, you make 0 volt, but the electron still can flow. The electron that ejected still can flow to the anode, okay, because it receive energy from the light. It receive energy from the light, the photon energy, which is E equal to HF energy. Okay, it receive energy from the light. Okay, this is the what we call light energy. All right. So that's why even 0 volt, there are still current. There are still current flow. Yeah, the current still flow in the circuit. Actually, the current should flow in the opposite direction, opposite from the electron. So even though 0 voltage, there are still current, but we put as current I naught. I naught is the current at 0 voltage. Okay. So it has certain value like this I naught maybe is maybe at 1 ampere, although 0 voltage. Okay, why it still have current? Because this energy has this electron has kinetic energy. Why do the electron has kinetic energy? Because this kinetic energy of electron come from the energy of photon. So the energy of electron now is not come from battery, but it come from the light. Okay, that's why the electrons still flow in the circuit. The electron still flow in the circuit. And current is the flow of positive charge, yeah, opposite from the electron. Okay, so let's so we can say initially we put at 6 volt, 10 volt. 10 volt, you have 6 electron reach at anode. Now you decrease 10 volt, become 5 volt. Now 5 volt, at 5 volt become 5 electron reach at anode. Now 5 volt you decrease to 0 volt. 0 volt you still have 4 electron reach at anode. Why there are still 4 electron reach at anode? Because it still got kinetic energy after ejected by the photon. Okay, it still have kinetic energy from the light. So you see, at 0 voltage, the current is not equal to 0, but the current is equal to I naught. All right. So at 0 voltage, there are still I naught. So now, let's move on. What if now at 0 volt there are still, you see? So at 0 volt, there are still current. What if now I make the voltage become negative 10 volt? I reverse the voltage. I become negative 10. What will happen? I make the voltage negative. So this is what happened. If you make the voltage now negative, that means last time here is negative and here is positive. Okay, negative here, positive, and cathode is negative, anode is positive. Now the second part, I reverse. Now this part become positive and this part become negative. You see, I reverse already. I reverse the voltage. I'm reversing the power supply terminal. What happens if I reverse? Yeah, so from negative positive, now I reverse become positive negative. So now cathode is positive and anode is now negative. What if like that? I reverse. That means last time is 0 volt. Now I reverse become negative 10. Now I become, let's say, negative 10. Now it's negative 10 already. Negative 10 volt. What happened if negative voltage? So if negative voltage, last time at 0 volt, you have 4 electron, right? At 0 volt, you have 4 electron. Now I reverse it, become negative 10. Maybe now it's only 3 electron can reach. Now it's only 3 electron can reach. I reverse some more. Become negative 20. Only has now it only has 2 electron can reach. Negative 10 is 3 electron. You make it even more negative. Then become less and less electron can reach the anode. Now you make until, let's say, until where we call the stopping potential. The minimum voltage of the reverse potential or reverse voltage where there are no photoelectrons reach the anode. This is the most important thing. Okay, so at stopping potential, okay, stopping potential, there will be no photoelectron will reach the anode. That means stopping potential, maybe you applied stopping potential now. The stopping potential now is maybe negative 30. Negative 30, very negative already. Okay. Then at negative 30, maybe no more electron. 0 electron can reach. If 0 electron can reach, if now the no more electron can reach the anode, now what happened is it become, the current now is become 0. No more current. Do you see that? That's why you see this is the this part in front. Yeah, in front here is before reversing the terminal. What I'm saying is this one from 0, 10, 20, or positive 30. Yeah, and then we reverse, become negative 10. Yeah, here is a negative 30 volt. You see that? When you reverse the voltage, the current decrease. The current will decrease. The current will decrease until in the end current become 0. Here current becomes 0. Why current becomes 0? Because no more electron can reach the anode. 0 electron reach the anode already. Why is it reverse voltage? The electron cannot reach the anode. Because when you reverse voltage, last time is negative positive. Now it become positive negative. Positive negative means the anode now negative. Negative terminal will repel the electron. You see, last time when not reverse, it's like this. Maybe let me draw it out. Yeah, let me draw it out. Last time is when not reverse. This is the cathode. This is the anode. Okay, and this is the negative. This is negative and this is positive. So electron that is ejected can easily reach the anode because it is attracted by positive plate. It is attracted by positive plate. But now when you reverse the voltage, when you reverse, now the cathode become positive. Let me draw. When you reverse, this is the cathode, this is the anode. Now this cathode become positive, this become negative. So what happened is the electron now is being repelled. Maybe I draw it here. It's being repelled by the negative plate. It's being repelled. So less and less electron can reach the anode already because it's being repelled by the negative anode. It's being repelled. So the electron, although it can go to the although it has the kinetic energy to go to the anode, but not all can reach the anode. It's being repelled by the anode. So what happened is, what happened if repel? Look at this one. Look at this one, the stopping potential. Look at the stopping potential, look at this one. Now you see, you see here? This is the one. Now voltage is negative, voltage is negative. Now this is the anode now is the negative terminal, so look at the galvanometer. Galvanometer now is 0 current. Look at here. Look at what happened. You see the electron ejected. Where does it go? Does it reach the anode? No, it does not reach the anode. It is being repelled back. So no electron can reach the anode. That's why the current now is 0 at this stopping potential. You see, it tried to go but it cannot reach. See that? I try to go to the anode but it cannot reach. It's all being repelled. This is what we call stopping potential. Okay, you see the difference? Last time when 0 voltage, the electron can easily reach the anode. At 0 voltage means the neutral. These two terminal is neutral, no positive, negative. So the electron can easily go to anode because not being repelled by the terminal. Now if you reverse the voltage, here become negative terminal, it will start to repel the electron. It will start to repel the electron. So electron cannot reach the anode and the current becomes 0. Okay? Understand? So you see, when you reverse, the current will drop because it's maybe last time I said at it dropped because from last time I naught is 4 electron. Now you reverse the voltage, become 3 electron, 2 electron, at last become 0 electron. So current is 0. No electron can reach the anode. Okay. So okay, let us read again. So when the voltage is made negative, is made negative by reversing the power supply terminal, so the current will decrease even further to very low values because most electrons are being repelled by the anode, which is now negative. Okay, so now it become more negative. Less photoelectron will reach the anode, and the current will drop to 0. That means no photoelectron can reach the collector. Okay, so so the voltage at this point, voltage when the current is 0 is called stopping voltage, Vs, when no photoelectron reach the anode. So at stopping voltage, remember that at stopping voltage, current is 0. At stopping voltage, when stopping voltage, the current is 0. It means no electron can reach the anode. Okay, so by using conservation energy, the loss of kinetic energy of photoelectron is the gain in potential energy. So last time I said this one, Kmax kinetic energy equal to EVS. What is it? What is this about? This is the stopping potential. Yeah, as you can see, this one Vs, this Vs is the stopping potential. Okay, so what it mean by this one is what I can say is like this. Yeah, maybe redraw again. Now I already reverse the voltage. I reverse the voltage. This one is positive, negative, negative. Yeah. So this one is the potential applied now. The potential applied now is the reverse voltage. Yeah. The potential applied. Yeah. The potential applied now is the stopping potential. It's the stopping potential. So what happened is we know that this is the cathode. Yeah, this is the cathode. It received the energy from the light. Yeah, energy from the light. So E equal to HF. Let's say HF. Now this photon have enough energy to eject an electron. So an eject electron is being burst out. Yeah, and we learned that this one when the electron ejected, it has kinetic energy. HF become kinetic energy after overcome the work function. It has kinetic energy. So this electron ejected with kinetic energy, isn't it? When it has kinetic energy, means it is going with certain velocity. Yeah, it's going with maximum velocity at kinetic energy. That's why Kmax equal to half m v max. When maximum kinetic energy means it has maximum velocity. Okay, but we know that electron is being repelled by the anode. The anode now is negative. The anode now is negative. Cathode is positive. Now anode is negative. It repel. Is being repelled. Okay. The anode repel. Yeah, anode repel the electron. So when it repel the electron, this electron will slow down, isn't it? It slow down until finally here it becomes V equal to 0. So what happened to the kinetic energy? The kinetic energy now also become 0. So where is the energy gone? Where is the energy now? The energy now become potential energy. It become potential energy. So please write that down. Now it has become the potential energy. So this is about conservation energy. The potential difference across this is about electron charge. This is an electron charge. The charge of this is electron charge, and the voltage across the two plate is the stopping potential. Stopping potential. So we can use the conservation energy here. Change of kinetic energy equal to change of potential energy. Kinetic energy is the maximum kinetic energy. Okay, totally convert to potential energy. Understand or not? Totally convert to potential energy, and that's why we can Kmax is actually half mv max square. So delta U is actually Q delta V, isn't it? Delta U is actually Q delta V, and the charge involved is the electron. That's why this is the electron charge. And what's the potential difference across this plate? The stopping potential. So this is the one. Okay, the electron charge times stopping potential. Stopping potential, that means it will convert the whole thing, the whole Kmax, into potential energy. So finally the kinetic energy is 0. Yeah, just like shown over here. Over here the kinetic energy is maximum. Yeah, when the electron is near the cathode, it has maximum kinetic energy once ejected, but when you're going to anode, it's slowing down, it's slowing down until here. Kinetic energy is 0. You see that? Okay, let's go look at this one. So, what I say is here it has maximum kinetic energy. So this kinetic energy is changing to potential energy when it's being repelled by the anode. Yeah, when going nearer and nearer to the anode, this kinetic energy is changing to potential energy. And how much potential energy it change? It is the electron charge, the charge itself, electron charge times the stopping potential, the potential difference between the two plates, which is stopping potential. This stopping potential will stop the electron from Vmax become V0 until here. Okay, so the kinetic energy now is stored in the form of potential energy in the electron. Okay, so Kmax is also equal to, so the conclusion is Kmax is equal to half mVmax and also equal to EVS. So we have another formula, Kmax equal to half mVmax square and EVS. So that's the photoelectric effect experiment. Okay. So later on I will discuss about this photoelectric equation. Okay, thank you for watching.